Children, welcome to the crash course of chemistry. Today we will be doing the chapter acid, base and salt. I will be sharing the screen. All right. So just a minute. Yes. So when we hear the word acid, the first thing that comes to the mind is something sour in taste, right? So sourness is the general property or the physical property of an acid. So there are certain other general properties of acids. Let us see them one by one. The first one is the taste, which I mentioned just now. We have several examples for that. Like we have lemon, which is sour in taste. There are certain fruits like oranges, which are sour in taste. It is because they have acid present in them. Now, when we bring a litmus paper in contact with an acid, its color changes from blue to red, which indicates that the substance is acidic in nature. So a litmus paper will always change the color of blue litmus to red. The third one is methyl orange. Methyl orange is a synthetic indicator, which again indicates whether the given substance is acid or not. The moment it changes the color from orange to pink when in contact with the substance, then we get to know it is acidic in nature. The way we have methyl orange, we have another synthetic indicator called phenolphthalein, which originally is colorless, but when it comes in contact with an acid, you won't see any change into it. It means it remains colorless. So this shows that the substance is acidic in nature. And then there is no change with the turmeric either. An acidic substance will not change the color of turmeric. It will remain yellow. So children, the listed properties are the physical properties of an acid. And these are also called the general properties. Now we'll see the general properties of bases. Bases are bitter to taste. Like we have bitter gourd, which is bitter in taste because it has a natural base into it. It will change the color of litmus from red to blue. And phenolphthalein, which I said originally is colorless, will become pink when in contact with the base. Methyl orange, which originally is orange in color, will become yellow. The turmeric, which is originally yellow in color, will become pink or red when it comes in contact with the base. The general observation you must have seen, if you have a curry stain on a cloth and you are washing it with soap or detergent, the curry stain, which is yellow in color because of turmeric into it, becomes red in color. Because as I said, soap or detergent, they are basic in nature. And finally, when you feel them with your fingers, they will feel soapy because soap is having base into it. Soap is made out of base. So these are the general properties of bases. Now, suppose if you are given some test tubes with some unknown substance into it in the lab, and you are told to identify the substance, whether it is acidic or basic in nature, you can use these indicators, litmus or phenolphthalein or methyl orange. You can use them and you will get to know, you will be able to identify whether the unknown substance is acidic or basic in nature. like what is the response of acidic substance or basic substance with the litmus, methyl orange or phenolphthalein. So you can note it down or you can take the screenshot of this thing, which will help you to answer 1-mark questions. This question says that you have been given 3 test tubes. One of them contains distilled water, the other one has acidic solution and base solution into it. And you have just one litmus paper, the red litmus paper. So how do you identify the substance? Which substance contains what? So in this one, you can take the red litmus paper, you dip in one of the test tube. 2 things may happen. Either the color will change to blue or it will remain as it is red. If the color changes, then you get to know that the given substance is basic in nature. If the color does not change, it can be acidic or neutral. Then the same litmus paper which changed to blue, you can use to identify the other 2 test tubes. In one of the test tube, the color will change from blue to red, indicating it is an acidic substance. If the color does not change, it is a neutral substance. So basically, one red litmus paper can help you identify the substance, whether it is acidic, basic, or neutral substance. All right. So this is the answer to the question. Now, preparing an indicator of your own. It is easy, simple to prepare an indicator at home. You need a few things. Basically, you can either have a red cabbage or you can either have a red cabbage or you can have the beetroot. What you can do is you shred them into pieces. Which one, any of this you can have. You shred them to pieces and you boil them for 5 to 7 minutes in water. And after that, you let it cool down and then you strain it. Your natural indicator is ready. It is this simple to make the indicator. Now you can use this indicator to test various substances which are available at home, like milk or tea or toothpaste or saliva or cold drink, right? So these are the things which you can test easily. You will see that this natural indicator, which is originally purple in color, will give different shades. Like with acidic substances, it gives shades of red. With basic substances, it gives shades of blue. And with neutral substances, it becomes green. So depending on the change in color, you can identify if the substance is acidic, basic, or neutral in nature, right? So this was about the indicators, the indicator which you can prepare at home. Now there are certain other indicators which work on the basis of smell. Let me erase all this. Okay. Some indicators are based on smell. They smell differently in acidic medium and they give some other smell in basic medium. So they are also called olfactory indicators. Olfactory indicators, just because we have a nerve connecting the brain and the ear. Sorry, the brain and the nose. It helps you sense your surrounding on the basis of smell, right? So that is why they are called olfactory indicators. We'll see some examples. You can see the definition, right? The examples are onion. Onion is an indicator which will give a characteristic smell with acid, and the smell will disappear with the base. It shows a cloth soaked in onion juice. These are two pieces of clothes that are soaked in onion juice. On one of the cloth, you pour HCl, which is hydrochloric acid, and on the other one, you put some sodium hydroxide, which is a base, or you can use soap or detergent in place of it, because as I already mentioned, these are made out of base. So here you will have a characteristic smell. You must have experienced the onion soaked in vinegar, the smell of the onion that are soaked in vinegar. They become pink in color, right? And they have a different smell. They don't smell like onion anymore when you put it in vinegar. Vinegar is an acid, vanilla essence. In one of them, hydrochloric acid is poured, you will have a pleasant smell. And in the other one, you have a base with vanilla essence, the smell destroys. So the bases remove the smell of certain substances. So you want, so this is the second example. And finally, we have clove oil. Here also, you have different smell with the acid and base. Now, someone has to be very sensitive to sense the smell. Everyone is not equally sensitive. Everyone cannot identify the smell so fast or so accurately. So these olfactory indicators are not considered very accurate. They are not considered very accurate, right? So the ones which change the color, the indicators which change the color are considered or are preferred over olfactory indicators, right? So here you can have a question like, which one is preferable? Olfactory indicators or the indicators which are based on the change in color. So now we have the chemical reactions. We'll see the chemical reactions one by one. The first one is you can see the equation here. This you can identify. This is dilute sulfuric acid, right? It is reacting with zinc. Now, zinc is a metal. When zinc reacts with acid, you get zinc sulfate, which is a salt, and this is hydrogen gas, right? So this is one equation. The other equation is also a similar one. It shows another acid. This is hydrochloric acid. This is hydrochloric acid. Hydrochloric acid is reacting with zinc metal to give zinc chloride. Now this is another salt. Here also you get hydrogen gas. So when you see these two equations, you can conclude something out of it. You can conclude that whenever an acid reacts with a metal, you get two things. One is the salt and the other one is the hydrogen gas. So this is the general equation. An acid reacts with metal to give salt and hydrogen gas, right? Now these are the names of the reactants and the products which you already know. Okay. So here we see a diagram. In this diagram, you can see a test tube is shown. In this test tube, there is some liquid taken. This liquid is an acid. Okay. And there are some solid pieces shown. These are the pieces of some metal. And you can see the bubbles here. The bubbles indicate the presence of a gas. So now let us see. The test tube contains dilute hydrochloric acid, and the pieces are of the metal. I hope everyone knows what is Fe. This is metal ion. And in the last slide we discussed, whenever an acid reacts with metal, we get hydrogen gas. So the bubbles are of hydrogen gas. These bubbles are of hydrogen gas, right? So this test tube is there in front of you. Now we see one more test tube. In this test tube, again you see a liquid. This liquid is again dilute hydrochloric acid. There are some other pieces you can see here, gray colored pieces. These are the pieces of zinc metal, another metal. So it is quite obvious that the bubbles are of hydrogen gas, right? You can compare test tube number 1 with test tube number 2. Now we have the third test tube. Here again we have same hydrochloric acid, but this time we have magnesium, the pieces of magnesium. The gas is hydrogen. Again, compare test tube number 3 with first and second. And finally, we have another test tube having hydrochloric acid, but this time we have copper metal. But you don't see any hydrogen gas bubbles into it, right? So here we conclude one thing, and that is all the metals do not react with the same intensity with the acids. Different metals react with different intensity. Like here on the screen, you can see magnesium is most reactive because it gives so many bubbles with hydrogen. A lot of hydrogen gas is produced with acid. And the second one is zinc. Zinc is less reactive as compared to magnesium and is less reactive than both of them, but copper does not react at all. So we can arrange them in the decreasing order of reactivity, starting with magnesium. Then we have zinc, we have iron, and we have copper. Here only 4 metals were listed. But if you check the common metals which are available or the common metals which we use in our daily life, you will see the same observation. All metals are not reacting with the same intensity. So you can actually create a series of metals in the order of decreasing reactivity. Means when we go down the series, the reactivity decreases. The ones which are there on the top are most reactive. And when we reach the last metal, it is least reactive. Such a series of metals is called reactivity series. Reactivity series, or in some textbook you will find them as activity series, right? So this is the order. Now here you have very frequently asked questions, like you will be having some data in front of you with some common metals, like the acid used is hydrochloric acid, and certain metals like copper, magnesium, aluminium, zinc, they'll give you the amount of hydrogen gas produced, and then you will have to order them on the basis of decreasing or increasing reactivity. So once you know the amount of hydrogen produced, you can arrange them. Or the other one is a metal will displace the other one. Say for example, if I take a salt solution of zinc, if I take zinc sulfate and I make it react with magnesium, because magnesium is more reactive than zinc, it will displace it. And we'll have magnesium sulfate and zinc is free. right? So the data can be given in this way also. You can be given the common metals and whether the metal is being displaced or not displaced, displacement took place or not took place. On that basis, you can decide which metal is most reactive, which is least reactive. So such kind of questions are there on this topic, right? Now, which gas is usually liberated when an acid reacts with a metal? We just now have discussed it is hydrogen gas. And it is asking illustrate with an example. So any example you can take. You can take the example of magnesium and sulfuric acid. So we get magnesium sulfate along with hydrogen gas. And how will you test the presence of the gas? Now, children, this is the reaction where hydrogen gas is produced, but there are certain other reactions where carbon dioxide gas is produced. So we will simply see the bubbles in both the cases, whether it is CO2 or hydrogen, we will simply see the bubbles. And both are colorless gases. So we won't be able to make out which gas is produced. So there are certain chemical tests which help you understand that. The most common test for hydrogen gas is the pop sound test. Now, what is this test? Suppose you did this reaction in a test tube. You took the acid, say this is hydrochloric acid, and you have put some pieces of zinc or zinc granules into it, and the hydrogen gas is liberated here. So if you bring a burning candle, if you bring a burning candle near the mouth of the test tube, the candle will burn with a pop sound. The candle will the flame will extinguish with a pop sound, indicating that this is hydrogen gas. This happens because hydrogen is highly combustible. Hydrogen gas is highly combustible. So it explodes actually when you bring the burning candle near the hydrogen gas which was collected here, it explodes. And explosions are always accompanied with sound energy. So it is this pop sound that we hear. So whenever they ask you a question, how to confirm or how to verify the gas produced, this is the test for hydrogen gas, right? So now we have another reaction. We have again sulfuric acid here reacting with sodium carbonate. Sodium is a metal. So we can call it a metal carbonate. When acid reacts with metal carbonate, we can see a salt produced here. We can see water and carbon dioxide gas. Now, we will see one more reaction, then we'll conclude. Here you can see another acid, hydrochloric acid, and this is calcium carbonate. Again, this is a metal carbonate because calcium is a metal. So metal carbonate and acid is giving you this Ca has to be here. This is calcium carbonate, a salt, carbon dioxide gas, and water. So in both the reactions, we have the conclusion that whenever an acid is reacting with metal carbonate, we have three products: the salt, water, and carbon dioxide gas. Just because here we have a metal carbonate, the gas produced is carbon dioxide. You can relate it here. Because the substance, the reactant was a carbonate, we got the carbon dioxide gas, right? So here will be the same thing. If you have taken a test tube and you have the acid into it, and you have put some powder, I mean, this is available in powdered form, this sodium carbonate or calcium carbonate. If you put some powder of calcium carbonate or sodium carbonate into it, you will see some bubbles. This time the bubbles will be of carbon dioxide gas. So this is the conclusion here, right? In the next equation, we can see the acid, and this time we have metal bicarbonate or metal hydrogen carbonate. But the reaction is similar. We have salt, water, and carbon dioxide gas. So we can generalize here. Acid will always react with metal carbonate or metal hydrogen carbonate to give salt, carbon dioxide, and water. This is the general equation here. Now we need to verify, right? See, we need to verify what are the substances here. Just give me a minute. Names, which, as I said, you already know in class 10, you can identify the compound if the formula is given to you, right? This was seen in the last slide. Now, this can be done at home. It's very simple. This reaction is very simple. You just need vinegar and baking soda. This is vinegar. This is vinegar. We have it in our kitchen, and this is baking soda. So when you put some baking soda in vinegar, you see a lot of bubbles. Those bubbles are of carbon dioxide gas, right? And this is the salt produced. It is called sodium ethanoate. Sodium ethanoate is the IUPAC name, and sodium acetate is the common name. You can find it written both the ways. Either you will get it as sodium ethanoate or sodium acetate. It means the same. This is the salt, right? So you can see the picture here in this bowl. The lady is adding vinegar in baking soda. So a whole lot of bubbles are seen here, right? So why I'm mentioning these examples, so that like if you want to experience this, you can do such simple activities at home. Now, we saw just now that acid and metal carbonate or metal hydrogen carbonate will give salt, water, and CO2. So carbon dioxide is a gas. This time also you will see some bubbles, but we are not sure whether it is carbon dioxide or some other gas. So the way we saw a test for hydrogen gas, the pop sound test, we have another test for CO2 also. What you have to do is you take a test tube with some lime water into it. Lime water into it. The chemical name is calcium hydroxide. Calcium hydroxide solution is the lime water. It is colorless, right? You must have seen in the lab. It is colorless. But when you allow some carbon dioxide gas into, suppose this is a tube connected to the another test tube where carbon dioxide gas is produced. So this tube is taking carbon dioxide gas into lime water. When the reaction takes place, the lime water, which was colorless originally, becomes milky white. This is the observation that confirms that the gas produced is carbon dioxide. Now, why does this happen? Let us see. This lime water, which I told is calcium hydroxide, reacts with carbon dioxide gas to produce calcium carbonate along with water. Now, this calcium carbonate is a solid substance which does not dissolve in water. It is insoluble, precipitate. Because it is insoluble in water and because it is white in color, we see the lime water turning milky white. So this confirms that the gas is carbon dioxide gas. If you allow more amount of carbon dioxide to react with lime water, then it goes one more step further. Means in the first step, it became milky white. And if you keep passing CO2 gas into this milky white mixture, the contents again become colorless. Why does this happen? Because one more reaction takes place. Let me write it here on screen. Lime water and carbon dioxide in excess. So what happens is we get calcium hydrogen carbonate. Calcium hydrogen carbonate with water. Now this dissolves in water. And because this dissolves in water, the contents again become colorless. The solution again becomes clear. So the one which became milky before has become colorless again. So this is the confirmatory test for carbon dioxide production. And this can be a 2-mark question. They can ask you what happens when carbon dioxide is made to pass through lime water for a short duration and for long duration. So you need to write both the equations carrying 1 mark each. Right? So this is shown here. You can see this first test tube is the lime water. Here in the second one, this reaction took place. It became milky white. And in the third one, it became clear again because this reaction took place in the third one. All right. So here you have the common question based on the concept. Metal compound A reacts with dilute hydro. So we can frame the equation like this. A reacts with dilute hydrochloric acid. If you get such kind of questions in exam, go on solving them as you read it, the way I am doing. It produces effervescence. Effervescence means lot of bubbles produced, right? So it means it indicates some gas is produced. We don't know which one. The gas evolved extinguishes a burning candle. So one hint you got here, which gas it could be, but let us confirm. Let us read it further. Write a balanced chemical equation for the reaction if one of the compound produced is calcium chloride CaCl2, which is a salt. This is the salt. Now, it says that the candle extinguishes, the gas extinguishes the candle. So it is carbon dioxide gas because we very well know that this gas is used in fire extinguishers also. Let us now verify. So this is carbon dioxide gas is produced here. So in the previous slide, we have seen whenever an acid reacts with metal carbonate or metal bicarbonate, we get carbon dioxide gas along with salt. So it can be either calcium carbonate or calcium hydrogen carbonate, calcium bicarbonate. Right? So the question was you have to identify this and you have to write the balanced equation. So you can replace A with calcium carbonate and balancing can be done later on. So this is how these kind of questions can be solved. They could have extended the question asking you what is the third product formed here. So that is water. Now, the third property is calcium oxide and acid. You can see here, acid is reacting with calcium oxide. So we can call it a metal oxide. This is the salt here and water. Okay, one more equation, the same thing, acid and this is metal oxide. In the first one, we have calcium oxide. The second one is having copper oxide. We get salt and water. So the general equation here is acid and metal oxide will always give you salt and water. Here we have one more conclusion. Acid reacts with something to give salt and water, and that something is a base. This is the neutralization reaction. Neutralization reaction. So here we can conclude one more thing, that metallic oxides are basic in nature. They are basic in nature, right? So this is one. The second one is similar one. Acid reacts with metal hydroxide. This one was metal oxide, but here we have metal hydroxide. The same thing, products are the same, salt and water. So both metal oxide and metal hydroxide are basic in nature, right? So one practical application of this reaction is you must have heard people suffering from acidity. Acidity is a condition when if people overeat or eat spicy food or probably sometimes skip the meal, then more amount of acid is produced and it reaches the food pipe and it gives burning sensation or irritation, kind of heartburn, right? So that is called acidity. So it is because of the acid produced in the stomach. You know, you must have studied in bio, hydrochloric acid is produced in the stomach, which helps in digestion. So what happens is now this acid needs to be neutralized. So you should have some base. Now, the base which is used here has to be edible and it has to be mild, not a strong one, because strong bases are equally corrosive as acids. So the common edible mild acids are baking soda. The brand name is Eno. You must have seen it in the advertisements. Eno is nothing but baking soda into it. So it helps in relieving acidity. The other one is milk of magnesia. Milk of magnesia, which actually is magnesium hydroxide, MgOH twice. Here it is sold as Digene. Digene is the brand name. So the practical application, as I told you, it gives relief in acidity. The question can be like, a person is suffering from heartburn or acidity. How will the person be relieved? So these are the two examples that can be given, either baking soda or milk of magnesia. And because these substances counter acidity, they are called antacids. They are anti-acids, so they are called antacids. Antacid is the common name for these substances, right? Now, any doubts so far, children? We have seen three properties, three chemical properties for acids and base. I mean acids. Any doubts? This is what I just now explained. Milk of magnesia. It is used as antacid. Let me reshare the screen so that I can get rid of this box. All right. So acid and metal, it's just a recap. You can unmute and answer. Any of you children? What do we get when acid reacts with metal? Is there anyone to answer? No one? No one? Metal, salt, and hydrogen. Yes, you can answer so that I understand you are getting it, children. acid and metal oxide, salt and water, right? Now, the next property is about HCl and NaOH. This is the acid, hydrochloric acid, and this is the base, sodium hydroxide. As you already know, the reaction between acid and base will give you salt and water. I mentioned it a few minutes back. So this is called neutralization reaction, right? The reaction between acid and base is neutralization reaction, just because we get the salt. So this is the NCERT question. What is neutralization reaction? Give two examples. So you can give any two examples. You can take any acid reacting with any base to give. Now this reaction actually takes place in the stomach if someone has used this antacid in case of acidity. So the salt produced here is magnesium chloride with the water. Right. Now we'll start the reaction or the properties of bases. In this reaction, you can see sodium hydroxide is reacting with metal zinc. You get salt. This is called sodium zincate. Sorry, zincate. Sodium zincate, and hydrogen gas is produced. And but this is not true with every base. All the bases do not react with all the metals. There are only two metals. The one is zinc, the other one is aluminium. They react. First equation we have seen, and if it reacts with the base, then we get sodium aluminate along with hydrogen. This is sodium aluminate. Sodium aluminate, right? So when they ask you the reaction of base and metal, these are the common ones. Okay. Now, what do all acids have in common? There is some similarity in all the acids, and that similarity is all of them have hydrogen in them. You can see the first one is hydrochloric acid, sulfuric acid, nitric acid, or acetic acid. All of them hydrogen, right? This, all of them have hydrogen, and that can be proven when they react with metal. Whenever they all react with metal, hydrogen gas is produced. So the first answer here is all acids have hydrogen in common. Here you can see 4 test tubes are shown with 4 different acids, and every test tube will have zinc metal into it, and we'll have hydrogen gas releasing everywhere. The only difference is the amount of hydrogen produced depends on the strength of the acid. Acetic acid is a weak acid, whereas sulfuric acid is a strong acid. So the hydrogen gas produced here in sulfuric acid will be more as compared to acetic acid, right? So this is one common thing. Another common thing between all acids is they conduct electricity. They all conduct electricity in AQUE, aqueous form. Aqueous form means in dissolved form. In dissolved form, they all conduct electricity. Now, to prove this, we need to understand an experiment. Let us see that. This is the setup of the experiment. Here you can see the beaker. It contains dilute hydrochloric acid solution means the presence of water is there. There are two iron nails having the support of a rubber cork here. Then we have the wire connected with the battery. There is a bulb over here, the switch, and connected with the other iron nail. So basically, this is the circuit here. When you set up this circuit, you will see that the bulb starts glowing. The bulb glows because the circuit is complete. The circuit got completed because the acid connected the two iron nails. There is no physical connection between the two iron nails. There is only the presence of acid. So it proves that the acids are good conductor of electricity. So if you have, this question can be asked in 5 mark. They can ask you to write an activity proving that acids are good conductor in aqueous solution. So you need, along with the diagram, so you need to draw the well labeled diagram and explain all this. So here two conclusions were there for the question, okay, what do all acids have in common? What do all acids have in common? For that, the first point is they all have hydrogen, which is released when they react with metal, and they all conduct electricity in aqueous form. These are the two points of answer here, right? Now, as I told you, all acids have hydrogen in them. The next question is it that all substances that contain hydrogen are acidic in nature? Like, for example, we have glucose. The formula for glucose is C6H12O6, right? It contains hydrogen into it. Is it acidic in nature? Or we have one more compound, CH3, CH2OH. This is alcohol, ethanol in particular. This also contains hydrogen. So is it acidic, these two substances? So if we need to find out whether they are acidic or not, we can use the same setup. What we have to do is, instead of dilute hydrochloric acid solution, let us have glucose solution. Rest of the things are the same. See that the bulb does not glow. The bulb does not glow. It indicates that the glucose did not conduct electricity, though it has hydrogen into it. It contains hydrogen. Same observation is with ethanol. Ethanol is already, it is diluted form or it is in liquid form. Even if you replace glucose with ethanol, you will see the bulb is not glowing. So it shows that all the substances which contain hydrogen are not acidic necessarily. It is not compulsory that all the substances which contain hydrogen are acidic in nature. But yes, all acids contain hydrogen in them, that is for sure. Right? So another question that they can ask you here is, show or write an activity to prove that all the substances which contain hydrogen are not acidic. So same example you can take here for glucose and ethanol. You can draw the diagram as shown here, and then you can write, with the glucose solution or ethanol solution, the bulb is not glowing, indicating these are not good conductors. So they don't behave like acids, right? So today we discussed the chemical properties of acids and bases. We saw how they react with the metals, with metal carbonate, with metal oxides, how they both of them react together. And we also discussed the common substances acids have. And the third point we discussed is all the substances that contain hydrogen are not acids. So revise for the day, children. And any doubts, we can discuss it in the